Hello students, welcome to the class. I hope all of you are doing good so far. My name is Deepak Khandelwal and I am mathematics faculty for JEE. So today we are going to have a wonderful session on quadratic equations. So already you all are aware of quadratic equations. The equation which have degree 2 and degree means highest power of the variable should be 2. So standard form of a quadratic is ax square plus bx plus c equal to 0, where a is not 0, right? A is not 0 because if a is 0 then this term ax square term will be 0. So now it has become linear, not quadratic, right? So condition is a should not be 0. So this is the standard form of quadratic. Then in earlier classes you have already read formula for sum of roots, product of roots, nature of roots, right? So again, first of all, we are recalling all those formula, we are driving them, and then we will move ahead, right? So first of all, its degree is 2, so that's why quadratic will have 2 roots, right? We are already aware of this. So for a quadratic, it has 2 roots. Let's consider roots are alpha comma beta. Okay, so now we are interested in finding sum of roots, product of roots, difference of roots, right? So first of all, if roots are alpha comma beta, then this quadratic should be in the form of x minus alpha into x minus beta, because at x equal to alpha this whole will result in 0, at x equal to beta this whole will result in 0. But we know that if we add a constant, like if we put a constant here k, now also roots are alpha comma beta, right? So to balance it out, we can say the quadratic should be in this form: ax square plus bx plus c equal to k times x minus alpha x minus beta. Okay, so now we are comparing coefficients because it's an identity. Actually it is true for all the values of x, so we can compare coefficients. Okay, so here it is written ax square plus bx plus c, simplifying this side. So here it is k times x into x will result in x square, then minus alpha x and minus beta x. What are we doing? We are multiplying these terms and we are finding the terms containing x. So minus alpha x minus beta x, it can be written as minus alpha plus beta x, and then next minus alpha into minus beta, which is alpha beta, right? So we have multiplied all the terms. Okay, so now let's take this k inside. It is kx square minus k times alpha plus beta x plus k times alpha beta, right? Okay, now we are comparing this RHS side from LHS side. So now it is quite visible that coefficient of x square is k, here coefficient of x square is a. So it means if we compare coefficients, then a should be equal to k. Okay, fine. Next, now we are comparing the coefficients of x. Okay, so coefficient of x is here b, and here it is minus k times alpha plus beta. So we can say b should be equal to minus k times alpha plus beta, right? So now b is equal to minus k times alpha plus beta. So it means if we bring this k at LHS, so we are getting minus b upon k equal to alpha plus beta, and k is nothing but a, it can be replaced by a. So k is nothing but a, we have already proved it here in equation 1. Okay, so now it can be written as minus b upon k, b upon a. So from here we have got the formula for alpha plus beta. We call it sum of roots. Okay, so let me write it down. Sum of roots alpha plus beta equal to minus b upon a. Okay, similarly we can get the formula for product of roots. Okay, so sum of roots is here. Now formula for product of roots. Yes, now we are left with constant part. So compare constant part. So C should be equal to K times alpha beta. So we can say C is equal to K times alpha beta. If we bring K here, so it will become C upon K, and we have already got that K is equal to A. So we can say it is C upon A. So alpha into beta equal to C upon A. And this is the formula for product of roots, right? So product of roots is C upon A. So these are important results which you are supposed to keep in your mind. Okay, and one more important property from here, one more important result, that is, see, if we put K equal to A here, then you can observe that quadratic ax square plus bx plus c can be written in the form of A times x minus alpha into x minus beta, right? This is one more important result. It can save our time to solve some problems related with sum and product of roots, right? Okay, so now let's solve a question on the basis of it. Okay, so we are solving a PYQ. Let me check the question first. Okay, so we have a question which was asked in JEE Mains 2021. Let me write down the question first. Let alpha beta be two roots of the equation. So there is a quadratic equation, x square minus plus 20 raised to power 1 by 4x plus 5 raised to power 1 by 2 equal to 0. And its roots are alpha comma beta. Okay, so its roots are alpha comma beta. Then find alpha raised to power 8 plus beta raised to power 8. Okay, so we need to find. So this question is based on sum and product of roots. So let's see how can we compute alpha raised to power 8 plus beta raised to power 8. See, directly we do not have any formula for alpha raised to power 8 plus beta raised to power 8, but we can transform this expression in the forms of alpha plus beta and alpha into beta. How? See, alpha raised to power 8 plus beta raised to power 8, it can be written as alpha raised to power 4 whole square plus beta raised to power 4 whole square. Now you are familiar with this form. Now it can be written as alpha plus alpha raised to power 4 plus beta raised to power 4 whole square minus twice of alpha raised to power 4 into beta raised to power 4, right? You are already familiar with this. X square plus y square can be written as x plus y whole square minus twice of xy. So same expression here. This is working as x, alpha raised to power 4, beta raised to power 4 is working as y, right? Okay. So now, see, directly put the value of alpha into beta whole raised to power 4. We already know the value of alpha into beta. So we can directly replace this. Okay, so first of all, we are finding alpha into beta and alpha plus beta. So alpha plus beta equal to minus b upon a. And if we compare it with ax square plus bx plus c, so a is 1, b is 20 raised to power 1 by 4, and c is 5 raised to power 1 by 2. So alpha plus beta equal to minus of b upon a. A is 1, so this is the value of alpha plus beta. Now what about alpha into beta? That is c upon a, and c is 5 raised to power 1 by 2 upon 1. So that is 5 raised to power 1 by 2. 1 by 2 power means nothing but a square root. Yes, okay. So now it is alpha raised to power 4 plus beta raised to power 4 whole square minus twice of alpha into beta whole raised to power 4. So 5 raised to power 1 by 2 whole raised to power 4. So it is nothing but 5 square. 5 square means 25. Okay. So we can say it is nothing but 25. 2 into 25. Okay. Now what about alpha raised to power 4 plus beta raised to power 4? So again apply the same formula, because alpha raised to power 4 is nothing but alpha square whole square, beta raised to power 4 beta square whole square. So same type of formula. How? See, alpha raised to power 4 plus beta raised to power 4 can be written as alpha square plus beta square whole square alpha square plus beta square whole square minus twice of alpha square into beta square, and then here is whole square over it, and minus 2 into 25, which is 50, right? Again we know the value of alpha square into beta square, because it is nothing but alpha into beta whole square, and alpha beta we have already computed, so directly we will just substitute the value of alpha into beta there. Okay, so now we are left with alpha square plus beta square whole square minus twice of alpha into beta whole square. So it will be 5 raised to power 1 by 2 and s square. So 2 will cancel out 2. So it is simply 5. Okay, so we can say it is 5, and 2 into 5 is 10 minus 50. Now what about this alpha square plus beta square? So again apply the same formula. It can be written as alpha plus beta whole square minus 2 alpha beta. So again it is nothing but alpha plus beta is nothing but alpha plus beta whole square minus 2 alpha beta, and then there is whole square over this, right? So it is alpha square plus beta square whole square, then we have put its value 10 and minus 50 there. Okay, so now alpha plus beta is minus 20 raised to power 1 by 4. It is nothing but minus 20 raised to power 1 by 4, and it's a square there. Okay, minus twice of alpha into beta is nothing but 5 raised to power 1 by 2, and then there is the square, then minus 10, and again it's whole square, and then minus 50 over there. Okay, so now here T 2 will cancel out 2 times, so we are left with minus square is plus, so term will be positive, so we are left with 20 raised to power 1 by 2 minus 2 into 5 raised to power 1 by 2. Actually it is written 2 root 5. If we bring this 2 inside, then it will become root 20. Root 20 is nothing but 20 raised to power 1 by 2. So terms will cancel out. Okay, so we can write it down as 20 raised to power 1 by 2. Then it's whole square, so again it will make no sense here, because 0 square is 0. Then minus 10, and again whole square over this, and then minus 50. Okay, so 0 square is 0, 10 square is 100, minus 50, which results in 50. So this is the answer for this particular question. So this question was asked in JEE Mains 2021. So JEE is most of the time JEE is asking questions from here actually. Yes. Okay, so now moving ahead. See, now next we are interested in difference of roots, right? So how do we find difference of roots? So first of all, if quadratic is ax square plus bx plus c equal to 0 in standard form where a is not 0, so its roots are alpha comma beta. Now what is the value of alpha beta? We have read this formula, Sridharacharya formula, and now I am not going into the proof of it. Actually by just completing square method, you can derive it. I am just writing the values of alpha comma beta formula. How do we determine it? So it is nothing but minus b plus minus root over b square minus 4ac upon 2a, right? And we are already aware with b square minus 4ac, it is nothing but it is called d, discriminant of quadratic, right? So d equal to b square minus 4ac. So this formula can be written as alpha comma beta equal to minus b plus minus root d over 2. Yes, okay. Now if we are going with plus sign, we call it alpha, minus b plus root d upon 2a. If we are going with negative sign, minus b minus root d upon 2a, then we call it beta. Now we are interested in the difference alpha minus beta. So alpha minus beta, so we just need to subtract both the numbers, both the values actually. So alpha is minus b plus root d upon 2a, and beta is minus b minus root d upon 2a, right? So we can see this minus b plus b will be cancelled out because denominator is same 2a, and we are getting root d plus root d. We are getting root d plus root d, which is 2 root d upon 2a. So we'll cancel out. So we are getting alpha minus beta equal to root d upon a. Okay, now here is a catch. Actually we do not know which one root, alpha or beta, which one root is greater or larger. So we cannot say whether alpha minus beta is positive or negative, but whenever we use the term difference, so difference means always we are considering positive difference. So we can say, we can put mode over there, like positive difference, right? Okay, so you need to remember this formula, alpha minus beta equal to mode of root d upon, this is the formula for difference. Okay, so now moving ahead. So till here we have derived formula for sum of roots, product of roots, and difference of roots. Out. Now let me give you one important information. See, a quadratic is there, ax square plus bx plus c equal to 0, where a is not 0 in standard form, right? Now if anyhow we are getting more than two values of x which are satisfying this quadratic, then this is no longer a quadratic equation, because quadratic has two roots. If we are getting more than two values of x, more than two roots, then it is no longer a quadratic. Then in that case we call it identity. So what I have tell you, if alpha beta gamma, these are the three values of x, if alpha beta gamma satisfy the given quadratic, then it's an identity. And it is not a quadratic, it's an identity. Identity means it is true for all the values of x. So if it is an identity, then at LHS side there should be 0, because 0 equal to 0, because it is true for all x. So we can say it is true for all x. Ax square plus bx plus c equal to 0 for all x belonging to R. So it means at LHS if it is 0 every time, so we can say that a, b and c, all three should be 0. Yes, all the coefficients should be 0. So then a equal to 0, b equal to 0, c equal to 0. Actually sometimes questions are asked on the basis of this information, or it is used many times in between the questions, right? So you always need to pay attention. If quadratic has more than two roots, then its coefficients are equal to 0. So let's solve a question on the basis of this information. Consider a quadratic equation a minus b x square plus b minus cx plus c minus a equal to 0. Here a minus b x square plus b minus cx plus c minus a equal to 0, where a, b, c belongs to R. These all are real numbers, right? So now what is the information given? Information is, for this quadratic, if ABC belongs to R and one of its root is one of the roots of quadratic is is 3 plus root minus 2, then find the relation between A, B and C. A, B and C. Right, this is the question. Quadratic is given, one of the roots is given, that is 3 plus root 2 iota, 3 plus root minus 2, which is 3 plus 2 iota. Then we need to find the relation between A, B and C. Okay, so how can we approach this problem? See, first of all, if ABC belongs to R, it means all the coefficients A minus B, B minus C, C minus A, these all are rational numbers. So if, sorry, these all are real numbers. So if all the coefficients are real, then imaginary roots should appear in pair. Like roots should be conjugate, because we have read the formula for the roots of quadratic. We have read the formula that root is alpha equal to minus b plus root d upon 2a, beta equal to minus b minus root d upon 2a. So if A, B and C all are real numbers, right? So from where we will get imaginary number? Imaginary number, we'll get imaginary number from this part, from root part, from here only. And now we can see this part is being added or being subtracted to all the real numbers. So if, let's have a look at the root. If it is 3 plus 2 iota, so then next should be 3 minus 2 iota, and this is nothing but root d, right? So if A, B, C are real numbers, then imaginary roots appear in pair, because imaginary number will occur from here only, from root d part only, right? So it is one time it is being added and one time it is being subtracted, so that's why the roots always appear in pair. Okay, conjugate pair. Okay, so now there is nothing in this question. If we can write down this, A, B, C belongs to R, then imaginary roots will appear in pair. Okay, so if roots are in pair, so we can say its two roots are 3 plus 2 iota and 3 minus 2 iota. Now how can we find relation between A, B and C? Well, we have two information, we have two roots, and we need to find the value of three unknowns A, B and C, like relation between A, B and C. See, there is one more information hidden. Actually we can see coefficients are in cyclic order, A minus B, B minus C, C minus A. If you add them up, you will get sum as 0. So it means x equal to 1 is also root of this quadratic. Check it out, put x equal to 1 there, put x equal to 1 in the quadratic, so you will get A minus B plus B minus C plus C minus A. Okay, so B cancel out, C cancel out, A cancel out, so it is equal to 0. So it is satisfying the given quadratic equation. So we can say x equal to 1 is a root. We can say here x equal to 1 is a root. Okay, so now we have got x equal to 1 is a root. We have got already two roots, 3 plus 2 iota, 3 minus 2 iota. So we can see that quadratic has more than 2 roots, and if a quadratic has more than 2 roots, then it's an identity, it's no more a quadratic. So it's an identity. So we can say given quadratic is an identity. So it is true for all the values of x. A minus bx square plus b minus cx plus c minus a equal to 0 for all x. For all x, right? Okay. So if it is an identity, then you know this. If it is an identity, then all the coefficients should be equal to 0. So when we equate them to 0, you will get a minus b equal to 0, which means a equal to b. From here b minus c equal to 0, which is b equal to c. From here c minus a equal to 0 is c equal to a. So we can say from here a equal to b equal to. So that's how we approach such kind of problems, and that's how we use that particular information. Okay, so now moving ahead. Okay, so now next topic is common root condition, right? And it's very important topic. Many times JEE has asked questions in mains and advanced level as well from this topic, from this particular segment. So common root condition, CRC. Okay, so as name itself suggests, there are gonna be two quadratic equations which share a common root, which share a common root, which share one common root, or which can share two roots as well. Okay, so let's have a look. Let's consider two quadratic equations. A1x square plus b1x plus c1 equal to 0, and a2x square plus b2x plus c2 equal to 0, right? Now first of all, if both the roots are common in given quadratic, then you are already aware of this information. If both the roots are common, if both the roots are common, then both the quadratic equations are same actually, right? They are the constant multiple of each other. Like second quadratic is 5 times of first one, k times of first one, right? So it means the ratio of all the coefficients should be same. Both the roots are common. So it means a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Okay, so this is the condition for both the roots being common. And it is quite easy. We are not interested in this part as much. We are interested in finding the condition for a single common root, right? Okay, so now what if exactly one root is common? Exactly one common root. Now we are interested in this part. Okay, so if one root is common, then it should satisfy the equation. Let's say common root is alpha. So alpha is the root of first equation as well as root of the second equation. So a1 alpha square plus b1 alpha plus c1 equal to 0, and similarly a2 alpha square plus b2 alpha plus c2 equal to 0, right? Alpha will satisfy both the equations. Okay, so now you know how to solve two equations using cross multiplication method. You have already read in junior classes. Okay, so from here, if we are considering alpha square is separate variable and alpha is separate variable, then by using cross multiplication method we can say that alpha square is equal to, how do we find it? b1 c2 minus b2 c1, right? We cross multiply them and then divide them by a1 b2 minus a2 b1. So this is the value of alpha square. Okay, Yes. So what? A1 B2 minus 2 B1, right? Now how are we getting the value of alpha? So see, equations were A1 alpha square plus B1 alpha plus C1 equal to 0 and A2 alpha square plus B2 alpha plus C2 equal to 0. So now how are we finding alpha? So again, now you know that we shift A1 A2 here and then C1 A2 minus C2 A1 upon A1 B2 minus A2 B1, right? Okay, so alpha is equal to C1 A2 minus C2 A1 upon A1 B2 C2 B1, right? Now this is the value of alpha square, this is alpha. So we can say that if we square this term, then it will become alpha square and it will become this part. So now this is the value of alpha square, this is also alpha square, so RHS part should be same. So now we can say B1 C2 minus B2 C1 upon A1 B2 minus A2 B1, it should be equal to C1 A2 minus C2 A1 upon A1 B2 minus A2 B1 whole square, right? Yes. Okay, so now you can see A1 B2 minus A2 B1, so one power will be cancelled out from here and one power will be cancelled out, okay, and then one we will transpose here at the LHS side. So we are getting B1 C2 minus B2 C1 into A1 B2 minus A2 B1 is equal to, I think it is not visible, so let me write it down here. It is equal to C1 A2 minus C2 A1 whole square. This is the condition for one common root between two quadratics. This is called CRC, and actually there is one more method exists to find one common root or to solve problems involving such kind of applications. There is one more method, we will discuss about that later on. Yes, okay, so now you can use this method to check whether exactly one root is common or not. If two quadratics are given, if this condition is being satisfied, then surely they share a common root, and if condition is not being satisfied, then there is